Hi, I'm John McLoone, and I'm talking about Pricing Engine Package, which is a Wolfram language package for working out the price of Wolfram applications. And so it encodes business rules and exposes them over an API function to be used from business systems within the company. So this is an eating your own dog food type talk, because while most of what we do at Wolfram is about making clever stuff to give to all of you, we are also still an organization that has business systems and stuff that needs to work to keep us running as a company. So we're in the middle of a project at the moment to modernize our entire business system architecture. And this talk is about one small little fragment of that was thrown my direction as one of the few people who is both technical and has a history in sales, so understands things like how our licensing works. So the problem was to update the way that we work in a more modern way. There was a strategic decision to, whenever there's customization, to use our own technology to reduce dependency outside and only use outside tools where they kind of work off the shelf to do something that we really don't want to try and replicate. And then we have some particular issues. As a software company, we have huge combinatorial pricing complexity. So I tried to get an estimate of the different number of ways you can buy Mathematica, and it's somewhere in the order of 10,000. Now, a lot of the business systems around, and certainly some of the ones we're using, are very oriented towards physical products, where your inventory might be, to have 10,000 parts, you kind of need to be a Ford Motors or whatever. But to have 10,000 different software configurations, you can have this sort of explosive number of them. And having systems that are based around physical inventory, where things have an item number to that specific item that you have to track the stock of, don't really apply to software. So we wanted to kind of simplify the way we think about our main product lineup. And then another problem that we have is, at the moment, is a fragmented authority. So if you want to know the price of a license of Mathematica, there's a bunch of different places you can look. And they are not entirely synchronized. And so whenever we make changes, there's a big challenge to make sure that the prices that appear on our website that are presented to customers match the price that our ordering system expects to be entered, that match what is on the salesperson's desk who answers the telephone when you ask for clarification. And all of these things are coming from different places and creating a whole sort of authority complexity that we really just weren't getting any benefit from. So the task I was given was think about how we could produce a single authority that is the place that sets the price of everything that we do, so that everything else then can flow out of that point and things are computed, so we aren't listing tens of thousands of different prices. Now, it wasn't just a fix what's broken type problem. I saw this as an opportunity as well. So one thing that I wanted to get out of this was to try and expose and therefore hopefully eliminate inconsistency. And I have to bear some of the guilt for this. I've been around for a long time, and so since '92 I've probably contributed to some of the crazy inconsistent rules that we have. When you're going through the pricing, trying to understand why the price of a product is what it is, some of the things you're looking at, the rules embedded long in history, you have no idea why there's some weird special case for the way something works in the UK compared to somewhere else. I mean, one I can remember, because I was part of the decision, is the amount of discount you get for being a student and buying a student license is different in the UK than it is in the rest of Europe and in the US. And the reason for that was on that particular day when we decided student versions weren't selling very well in the UK, we thought, as a psychological point, we have to be under £100 including tax. So we set it nicely, and it made perfect sense at that time. And that was 15 years ago, and inflation's pushed things up. It's not a nice pound number anymore, but the rule that said that it's a cheaper ratio compared to a US student license has persisted long after it had any use. So part of my hope was that we could flush all those things out and actually have things to be really consistent around the world. So you don't get weird cases where something's better value than something else in one country, but in another country, the value's the other way around. And of course, the main holy grail of all of this is, can we just be more agile as a company? Can we make it easier to roll out new products, to do promos, to do kind of experiments? We did an experiment in the UK, just to give a context to this, that was we thought, let's try selling at a slightly higher price, but including free training, and see if that's something that helps to get people into the product better. And it took a team of 10 fairly intelligent people over an hour to argue about how we could possibly achieve this, because the UK pricing was intrinsically linked into the Scandinavian pricing in the way that we were architected. And I wanted a system where I could just type one line of code and that would be it, it would happen. And you can imagine taking this to extreme. One day the dream might be that we could do a promo where everyone gets a completely different promo and machine learning is figuring out what kind of person responds to which promo, rather than having to have some sort of human-led A/B experiment. We could do an A, B, C, D, E, F, G infinity experiment on and really learn from it in an automated way. But that's dreaming for the future for now. So here's the bit where the Wolfram technology comes in, is how to try and solve that. So this sort of broke down into a few bits. One was, first of all, could we, one thing we want to do is move away from strings and names of things. So there are products that have complicated names like Mathematica Professional Network Increment, and separately from a Mathematica Professional Network license. Could we represent the essence of a software product in a symbolic expression? So this is at the heart what the project was to do. It was to take a symbolic representation of a request for something that might come from the store or from a customer saying, I want to buy Mathematica. I'm in the United States. I'm not a student or an academic. I want it to have service. I want it to last forever. I don't want to rent the thing. It's a single machine, and I want to download the thing right now, and I only want one of them. So this is a set of keys that encapsulate the essence of a Mathematica license. Now, part of the complexity is that those keys are fairly generic across software, but they're not totally generic. So the key set might be slightly different if my access control wasn't single machine, it's unlimited. If I'm an academic site license and I want to buy an unlimited Mathematica setup, then there's an extra key needed, which is the technical student count. So the keys vary by product. If I buy a t-shirt, the key might be size and color, although this really makes more sense within the software. So we needed a flexible ontology for this, and this is basically what the thing's supposed to do. I put in the keys, and it says $2,700 in this case. Or I could change this thing here and say, let's be in France now, and recompute that, and now it switches into euros and says it's 3,445 euros. And if I change my use class to being a student, then we'll get some, okay, the key name is not student. I can't remember what the use class is for students. Is it students, plural? Well, okay, I obviously need to, oh no, there is some other issue here. No base price Premier Service, because student licenses do not come with Premier Service, so I actually have to say service type none. There is no configuration there. So pricing failure is a way for the system saying that is an invalid request, and the reason is that for that, the configuration you've given, I can't find what this product's price should be. Or the product Premier Services price, because there is no Premier Service for student licenses. So that's the first step, and while I'm listing all of these things as associations, actually we're going to move this over to being much more integrated into the Wolfram language. By everything I'm going to show here actually will be entities in the future. So there will be an entity for a product and an entity for things like the business rules. So the next step then is to try and move all of the definitions that these things depend on well away from the request. So what we wanted to do is to have the ability to describe products into the system in a symbolic way. And so here's the sort of basic sort of entity structure of that. It's an entity type product, and this particular entity is the Mathematica product. And then one of the key properties of the entity is something that we'll have as a base price for the thing. So we don't have to list out all of the prices, how that propagates through the system. There's this concept of a base price. And from that, we can compute your actual price depending on whether, all of these other dimensions that I showed. Trying to be as abstracted as possible, we invented a currency. Of course, everything's Wolfram, around Wolfram, so we got a Wolfram currency unit. And the idea of that was simply to not have any one currency be the price that we then compute from. By having something that's currency independent, we can then decide, okay, what if we want to raise prices around the world by 2% for inflation this year? All we have to do is change the currency conversion between this Wolfram currency unit and the US dollar and the pound and the yen and the euro. We don't have to revisit any of the definitions. So this number will stay in perpetuity. The base price of Mathematica will always be this 1,048 Wolfram currency units. And all that will change is the conversion over the next decade or so. It's vaguely equivalent to the single machine annual commercial $2,016 price, but that's going to in a few years' time, that'll be completely forgotten, and it'll be quite an arbitrary number. Also, while I'm sort of stripping it out here, one of the hopes here is that we can have this definition not just to find the pricing of a product, but by listing out the contents, that Mathematica contains a front end and a kernel, and maybe it contains some more granular components. We can start describing actually what this name Mathematica means in a world where we might have many more configurations of products, that Wolfram Finance Platform is just the same configuration, but the contents is longer because it's got things like Bloomberg Link and Reuters Link and the other things that come with Finance Platform. So in one place, we can define everything one would need to know about a product. So apart from actually writing the code, all you'd have to do for the business systems is write this little entity value, and the product would go live, and there'd probably be keys for short description and long description that might even populate things like the store. Now, the complexity of this is kept down by this concept of hierarchy. And in a sense, I had style sheets in the Mathematica front end in mind for this, that in the front end, you can say at a very local level, this word is in bold. But if you want the whole cell to be bold, you could do it at a cell level. Or if in fact, you're using a style sheet, you don't say anything about that because it goes up until it says, okay, we get to the style for section, and that happens to be in bold. So what I wanted to do was to hierarchically organize products as well, so that when you create a new product that is kind of like Mathematica but some other components, you don't have to spell out hundreds of keys of details. You can just say, it's like this product, but this is different. So the idea is it inherits anything that I haven't said here. It inherits from this Mathematica product class. And if it can't find it there, it inherits from software class. And if it can't find it there, it goes to product defaults. And so that's where the complexity lives. So here's the software class that this ultimately inherits from, which is where all the good stuff lives. And one of the key things here being this price WCU function. So this is where it defines how all these different dimensions come together. That the pricing for this class is quite simple. We just find these little things called price multipliers. So there is a price multiplier if you're commercial, and a different one if you're academic, and a different one if you're student. And then we multiply all these multipliers together, and multiplied also by the base price, which is, okay, there's the base price lookup. And there's a time period scaling I'll maybe mention later. And then there's complexity of service, which I think we can do better. But at the moment, there's a little bit of code here that says, well, if there's service, you have to make another lookup for that. So all kinds of stuff lives in here that is actually computed rather than values. And this is where the whole Wolfram language kind of gets useful, because we've got code for the pricing package, and we've got numbers like the base price. But then in the data, there are things that can be code as well. So data and code don't have to be completely separate. So within the database of all these business rules, we can have little snippets of code that say, for this particular value, well, it's complex. You have to do something to work out what the value is, not just look it up. Oh, and here's further up that hierarchy. You get to see some of the other keys that are in here. There's information that's needed for helping things to be taxable, whether or not we can allocate revenue. So if this thing had a royalty that needed to be paid to somebody else, does that get allocated? Trying to make things a little bit dependent on whether there are costs involved with things that have, for example, services where it actually costs us money to sell the thing. We don't want to necessarily discount that to be making a loss. And so there's all the little corner details, but it's just a case of just adding more keys to describe the concept at the right level in the hierarchy. And so this is, at the moment, you can see some bits we've sort of ignored so far. This is the map of the hierarchy. So you've got a whole bunch of applications that inherit from an application class. You've got a whole bunch of Mathematica-like products and then we've got a whole bunch of things like development platform tiers that inherit from a development platform, that inherit from the software class, all leading to product defaults. And then we've got this mess we've ignored of miscellaneous. So at the moment, T-shirts and pens and posters are all in a sack, and we're just kind of ignoring those for now. But at some point, you can imagine this being a big hierarchy of T-shirts, and under the T-shirt, all the designs, and under each of the designs, all the sizes or whatever. Of course, we can compute that stuff now because we have a symbolic representation of all of these products in the catalog. So we've got the product database that defines the product, and then we have to bring in the business rules. We're keeping those in a separate place because it's different people who have to think about them, and they have different kind of structures, but they're actually the same kind of idea. You've got an entity for an entity type of access control, which is how might you use the software, and then the different entities within that entity type are things like single machine, network license, public to the world like Web Mathematica is, unlimited if it's an unlimited license, and then various keys that go with them that say, so these are the two rules, for example, that define how network licenses price. If you've got a single machine license, we multiply the price by 1, i.e. that's the default. If you have a network license, network increments cost 30% more than single machine licenses. So in one line, we've encapsulated all network licenses across the entire product lineup, unless we insert exceptions. And this is where exceptions will really stand out, because you actually have to create a rule to stop things being automatically the same, rather than at the moment, the thing has been, everything needs a rule, and so you're always having to create a rule, and so whether you create one that's the same and consistent or one that's just random and different is equally the same effort. And now you have to create a rule to say, except in a certain circumstance, those rules will really stand out and need defense. And so here's how we do this kind of exceptions, is that there's a concept of restrictions that say this particular rule only applies if the product is in the class of cloud products. So I'm not actually sure what this is saying. It's saying that there are no cloud-only student licenses, which I'm not sure is correct, actually, but I'll have to revisit that rule. But it's saying if you're asked for a student multiplier, but you're in a cloud-only product class, then you're just going to use the commercial price. You don't get a special deal for students in that group. And then if you're a student in anything which is single machine or Wolfram ID based, then you get a 93% discount compared to the commercial price. And the product rules are also going to be about, as I said, things like promos and time-limited things. So the idea is that we have inheritance classes for different types of promos. So here the parent is something called a price proportion discount. That means it's going to give you some fraction off the price. But there's about, when I enumerated them, about 10 different classes of promo. There's like a price combination. Buy this and get something off. Or there is a kind of basket adjustment promo that says, if you buy this and this, we'll give you a free thing that you didn't ask for in the basket. So there's about a dozen of these, 10 or 12 of these different things. This is saying, in the case of this, it's a price proportion discount. You're going to ask for a promo code. It won't automatically work on this one, and it'll give you a discount, which is going to be 50% off if you buy 2 of these things. And then it's going to insert a key for, say, this is the reason for why you're being given a discount is a buy one, get one free discount. So then the process through the system is to augment keys. We start off with just the keys you ask for as the customer, and when we're done, we've inserted all kinds of keys to say, here's the price in local currency, here's the reason why we gave a discount, here's the discount we gave. And the whole thing's quite complicated, but I've got a little thing that makes it a little bit easier, that you can see that now all kinds of keys have been added to the thing, including to some extent the packing list of what's in this product, that when you ask for Mathematica, actually I'm going to get Mathematica and I'm going to get a service product. So now we've got a complete description of what you will own. All we have to do is basically copy that into the license database, and it's happened. It's just a copy over and throw out the keys that were only transitory. And then the final issue, before I wrap up for questions, is in the end, as I said, it's eating our own dog food, so the Wolfram language lets us do this whole symbolic architecture and mix data and code in subtle ways. But then we can push the thing out into our final deployment. There's no recoding step. We just do the usual thing of a cloud deploy of an API function. And now I can access this thing running off our own enterprise private cloud that is on our internal systems. And I can call that from things like our CRM system, from our web services system, from our accounting package, and say for this configuration, we get this JSON response back that I've decoded as being 2 rules here, which is a number and a currency. And that's the thing then that we have to tell the credit card company when we're actually going to execute. So like with most things, that whenever you get involved in technical products, you have no idea how complicated things are. They seem simple until you actually start coding. So there's all kinds of issues I won't have kind of time to talk about, how that execution works. And you know, we've all been having lots of meetings this week working some of those details out. But there are subtleties like time, that you think that we only sell things monthly, annually, or perpetually. But if you add an increment to a network license that you sold 11 months ago, or 3 months ago, you have to add it for 9 months because it has to synchronize. So in fact, time can be all kinds of different possibilities. And do you charge the monthly price times 9 or the annual price divided by times 3/4? There's a lot of little corner cases. Basket optimization. If I buy something with a promo code, but I buy lots of them, and the volume discount actually would have been better, we want to give you the best deal. So you might say, I want 50% off, and I want 100 of these. We want to be able to say, no, we're not going to give you 50% off like you thought you were going to get. Actually, because you buy 100, we'll give you 70% off because it's a volume discount. So figuring out all the permutations there is quite challenging. And we also want this to be a mechanism that will also support these repositories Stephen's talked about. So all you do when you create something to sell through an app store is create a rule in the pricing tables, and the same engine will make it possible to price automatically. So you can make a basket that's got a Mathematica in it and some $2 little piece of code that you sold in the App Store. You can make that in one purchase and it'll just work. And ducking at the moment, there are lots of fun issues to do with trust and permissions for external clients. I would love it to be the case that one day in product, you could purchase right through Mathematica, particularly for things like repository code. But also, we've got resellers around the world. And what happens now is they take an order from you, they enter it into their system, it generates a piece of paper or an email that gets sent to us for us to retype into our system and then execute the purchase. And wouldn't that be lovely if when they placed an order, they could call the API directly, and as soon as they've hit return, the thing has been actioned in our system rather than having this sort of delay of passing the message down when you buy through a third party. So there are lots of corner cases, any one of which I could give an hour talk about probably, and probably don't yet fully understand anyway, so it'd be an hour of not quite right talk.